My name is Sajid Pareed. In this lecture, I will give an overview of global evapotranspiration products which are ready to use and open access. After this lecture, you will be able to describe the different approaches in developing gridded ET products and give examples of open access ET products. There are multiple global ET products available as open access in the public domain. These products have a spatial resolution which varies significantly depending on the specifications. There are ET products available at a higher resolution of 30 meter to a much coarser resolution of 25 to 50 kilometer grids. Another important characteristic of these products, which is temporal resolution, and in this case, these datasets are available at a frequency of hourly, daily, decadal to monthly. Most of these products are near real-time, available with data latency of approximately 1 to 3 months. In this lecture, I will be focusing on those products which are updated regularly and near real-time. In general, the ET products can be broadly classified into three groups based on the methodology. They are land surface modeling products, reanalysis products, and remote sensing based products. In the first two categories of land surface modeling and reanalysis, evapotranspiration is a byproduct of larger modeling scheme addressing entire Earth's fluxes. But remote sensing based products in this case are tailored for ET estimates using satellite data. Some approaches like surface energy balance modeling using remote sensing data can be considered as subset of land surface modeling too. Land surface models are numerical models that simulate land surface processes such as absorption and partitioning of radiation, water, and carbon between the land surface and atmosphere. LSMs are often applied at large spatial scales, aimed to simulate the interactions between climate and land surface. These models, when provided with meteorological forcing as inputs, they estimate latent heat fluxes, sensible heat fluxes, and carbon fluxes as outputs. The schematic diagram here shows the overview of the simulated process in these models. In many of these models, in recent years, satellite data are used as inputs to represent the vegetation characteristics and land use. The table in this slide lists the two main land surface model based products which offer various global land surface variables including evapotranspiration. The spatial resolution and the temporal resolution at which these products are offered are listed here, including the source, the web URL source where you can download these datasets. Reanalysis models are widely used in meteorology and climatology to generate consistent datasets of past weather and climate conditions. These models combine observations from various sources, such as weather stations and satellites, and combine them with numerical weather prediction models to produce a gridded representation of historical weather patterns. This procedure, called data assimilation, is the core of this approach. The assimilated data, along with the numerical weather prediction model outputs, are combined to create a comprehensive representation of historical weather patterns and atmospheric conditions at a global or regional scale as shown in this figure. The outputs from these models are generally at a coarser spatial resolution compared to land surface models. The table here lists the major reanalysis products available as open access in public domain. The spatial and temporal resolution and the temporal coverage, along with the source where these data sets can be downloaded, are listed in this table. The remote sensing ET products are based on well-established tailored algorithms, primarily using thermal and optical data from satellites. These data from satellites are used to compute surface temperature and other vegetation indices, which represents key variables to map ET. The figure here shows various approaches being implemented using remote sensing data. Note that some of these methods, like Penman-Monteith and Priestley-Taylor approaches, are also used in land surface models. Using these approaches, there are multiple products available at higher spatial resolution at regional or global scale. The table here lists the global ET products which are developed using remote sensing approaches. The spatial and temporal resolution, the temporal coverage, and the source URL where these data sets can be downloaded are listed in this table. Note that one of the data called WAPOR, which is developed by the Food and Agriculture Organization, is currently available for Africa and Middle East, but it will be available globally at 300-meter resolution from July 2023. It's very important to know the uncertainty associated with each product to make a selection for a particular application. However, it is not easy to evaluate them due to sparsely available field measurements. In general, there are 4 approaches being implemented in the literature to evaluate these products. Reference comparison is where the data product is compared with flex measurements or ET computed from a water balance approach as shown in this figure. Intercomparison of the products is where the seasonal and annual trends from each product is compared to each other and evaluated. Uncertainty analysis shows how uncertainty of input data and model parameters propagate to ET model output, while sensitivity analysis shows how much each individual source of uncertainty affects or contributes to the output. Identifying these uncertainty sources and the spatial temporal distribution of these errors are less studied due to the complexity involved in that. The satellite-based diagnostic datasets are reported to have lower uncertainty estimates than land surface models, comparing with flex measurements. While some studies also reported that LSMs or land surface models have smallest root mean square difference at basin scale than satellite-based datasets, comparing with the water balance approach as shown in this figure. Many comparison studies, on the other hand, did not conclude on selecting a product with better accuracy. To conclude, ET is a byproduct from land surface models and reanalysis models. These are generally available at a very coarse resolution suitable only for global level studies. While remote sensing based products are dedicated ET approaches and dedicated ET products. These products are available at higher spatial resolution. The selection of the product depends on the user needs and the application. Thank you.